Hello, welcome back to my channel, and in this video I'm doing the Siglent SDS1104X E digital storage oscilloscope unboxing. Let's get into it.
It comes in this cardboard box. It is pretty big. It weighs like 3 kilos or so. Now let's open it. This is how it looks inside the box. There's the scope, a power cable, and there's some more cables and probes at the bottom. Let's take it out. What you'll get with the scope is a quick start guide, a certificate of calibration. You also get the usual power cord and USB cable, and you get 4 of these 100 megahertz probes. And with each probe, they're pretty simple 1 to 10 passive probes. They're pretty nice, and what you get with these probes is a little tool for adjusting a little tool for calibrating probes, some of these shoes for easier probing of the pins, and all these colorings, and also the RF ground spring for probing high frequency circuits. Now to the scope itself. So here's the scope itself. It looks pretty nice. On the front here you have the display. There's a power button, there's for your probe calibration, ground and the calibration port. Here's the 4 channels. Here the buttons for the 4 channels, turn them on. There's the for math function, reference, roll, search, all the trigger setups, the trigger level. Here's the horizontal time base, and you can adjust it. They're very nice pushable knobs. They have very nice feel to them. And when you push them, they auto zero, or for trigger, they set it to the 50% level. And here is the adjustment for all vertical channels. It's of course just one for all, and you have to select which one you want to adjust. Here you have all the other functions. There is the multi-function knob, which also doubles as intensity adjustment. There's your basic run setup, auto setup, decode, history, utility, and all these buttons. And it has a dual 1 gigasample per second, or if you're using all 4 channels, then it's 500 megasamples. Though if you want to get dual 1 gigasample, you have to use channel 1 and 3, because channels 1 and 2 have 1 ADC and channels 3 and 4, so you have to go on each separate ADCs to actually get the 1 gigasample. And it has on the back side, it says calibrated here, and there is here the power plug, and down here there is pass-fail trigger output, USB port for any additional features, USB cable port, and a LAN port. And also it has a USB on the front here. For these probes, they're pretty nice. You have this stop hooking on, or if you want, you can remove, and you have this point for probing in the circuit. Here's also the ground lead, which you can remove and add the ground spring, so you have less noise and less inductance. They're pretty nice probes, and as I said, with each probe you get this bag of accessories, and you get the calibration screwdriver, this for probing pins, for easier aiming of the pins, and there's a normal one to just isolate the ground so you don't short it anywhere. And then you have all these colorings, and of course the ground spring, which you would just attach, and you remove this, and yeah, it's pretty nice. Now let's power the scope up. So you plug in the power, and on the back you have these very nice feet, and on the back side these very nice rubber bumpers. And the turn on time isn't that long. And it does all the self-calibration and everything, and tests all channels and everything. And there. Now let's look at some of the scope's features. But before we do that, we have to calibrate the probes. So to do that, all you need to do is connect the probe to the scope, and it's gonna be easier if you turn off all the channels. So you take your probe, and on front of the scope there's these two ports, calibration, and one is for the ground lead. So you connect the ground lead and the other to calibration, and you see the signal looks pretty small, so to make this easier you just press the auto setup button and it will adjust all the settings to make the signal look right on the screen. And you see this probe needs calibrating, and also the probe needs to be set in the 10x mode for calibration, to calibrate it. And to calibrate it you take this included tool and you find the calibration screw right on the scope here, right here. And then you need to adjust it so that it looks like a square wave and there's no like spikes on top or going inwards. It needs to be a perfect square wave. So you just put your tool in and hold your tongue at the right angle and you calibrate it. Yep, that looks right. And now you just repeat that for all three other probes. Now all four probes have been calibrated. Here on the display it shows, let me take it. Here on the display it shows in what mode the probe is, and all are now set to 1x. So I'm going to change that, and to change that you just press the channel button, and here, no, that turned it off. To select you select the channel, and then down here it says probe, and you press this here, and then with this adjustment knob you select the 10x. No, not 20. It can be a bit tricky sometimes. And then repeat that for all four channels. Of course, if you're using probes in 1x mode, then you leave it at 1x. So yeah, that's all probes set now. And on here on the probe menu you have you can select the coupling. There's DC, AC, and ground, which basically just internally connects it to ground. So that's DC, AC, ground. Yeah. Here you can set your bandwidth limit to 20 megahertz, enable or disable it. And this is the coarse and fine adjustment. So fine adjustment you go in steps of in small steps, and in full one it's bigger steps. And you can also choose fine or coarse by pressing on the vertical adjustment knob. Here, as I said, is the probe adjustment, and there's you go to the next page. Here you can choose the units. If you're measuring like amps, then you set it to amps. Here you can set your D skew, Here you can invert the signal, and let me connect and show you how that looks. So let me turn this off so it's easier to see. So here's the signal, and the inverter will basically just invert it to the other side, like this. It just basically inverts the signal. Here you can set the offset, which you can also set with this. With this knob, you can also set the offset, and you press it into 0 it. Here you can make the trace hidden. And on the last page, you can add a label to it, like, for example, channel 1. Let's do channel 1. And then just confirm it and display, and it here on the side shows channel 1 as your label. Here are the measure functions. Up here there's the measure, where you select on which channel you want to add the measure functions, and here you choose the type. There's peak to peak, maximum, minimum, amplitude, which is basically the full amplitude, the top one, the topmost value, and here at the bottom it shows very useful tips of what that mode does. There's the base, mean, cycle mean, standard deviation, cycle standard deviation, RMS, cycle RMS, FOV, FPRE, FOV, RPRE, level at X, period frequency, the positive pulse width, negative pulse width, rise time, fall time, bandwidth, duty cycle, negative duty cycle, delay, time at level, and then channel delay. Let's for now set for this one peak to peak and maximum, and the frequency, so we can read the frequency of it, and it's as expected 1 kilohertz, which is the output signal of here. What else you can get here in measure functions? You can clear them all, or clear any one of them. Then are the statistics. Here it shows you for the measured item peak to peak, max and frequency. It shows you the current value, the mean value, minimum, maximum, and the standard deviation, and how many counts it has done. Let me zoom in. So yeah, and then you can turn on the statistics, and here's the all measure, which will measure all the values, and they're here: peak to peak, top, standard deviation, and everything. Then here you can set the gate for the measurement. The gate R, A point, B point. Yeah, there's gate A, B, yeah. That's a pretty useful function for measuring something, so you don't have to count and then calculate. Next, we're gonna check the cursors menu. Up here there's the cursors button, and it sets a cursor to any point, and it will show the value at that point. There's 2 cursors, and it will set, I think, between those 2 points. You can choose the manual mode. There's the track mode, track or manual mode, where it tracks the signal. There's the delay, and there's the acquire. For the acquisition, there's a normal, peak detect, average, and E resolution. I don't know what it is. And you can turn here. You can also turn the XY mode on, which basically uses first 2 channels as XY mode, and we'll draw it as that. And here you can also set the memory depth to 14, to 14,000, 140,000, 1.5 meg, and 14 meg. And then there's the sequence, and on the second page you have what interpolation you use, sign on X, interpolation or just X. And there's the acquisition mode, fast or slow. I'm gonna leave it at fast. So next we're gonna look at the display menu. Here you can either vectors or dots. If you zoom in, it's gonna be dots here. And as vectors, it completes those dots as a line. So you can switch between just dots or a line. And the color grade shows that where the signal repeats at the most, like red is, it repeats the most there, and blue is where it repeats the less. And the persist is, the signal just persists, so you can move it and it persists there. Yeah. That's more visible when you remove the trigger, so you can see like it persists there. It leaves these lines where it persists, and then you can turn that off. Or clear it with clear display, or up here, clear sweeps. Yeah. Now let's look at the trigger. So trigger set so your signal doesn't like run around in place, so you set it so it stays in place. In the trigger setup, you can set what trigger you want. There's the options edge, which is either the rising or falling edge, as it shows you here in these very useful tips. There's the slope, pulse, video, for TV video signals, window, interval, dropout, runt, pattern, and serial. This scope is a very nice very nice function to decode serial signals, which can be pretty useful if you work with digital circuitry and stuff. But yeah, I'm gonna leave it on edge. Here you can choose the trigger source. There is channel 1 through channel 4 and the AC line. Here's the slope, which you use rising, falling, or alternating. There's the hold up time, coupling, DC, AC, low frequency reject, high frequency reject, and then there's the noise reject, which rejects the noise. And other trigger options here include the auto. There's the normal, where it triggers once the trigger. If there's like a pulse, there would be, and it would trigger when it passes the trigger level, which you set with this knob, and by pressing it, it goes to the 50% level of your waveform. And then there's the single trigger, which just triggers it, so you have to press it like there's nothing, and then you're gone. It also stops it with the run stop, and you can always press the run stop when you're in auto mode to capture it, and then you can zoom in and check your signal. As I said, the auto setup just sets the most optimal place of the waveform, so it displays it very well on the full display. On the horizontal adjustment, you can zoom in. It goes down to 1 nanosecond and all the way up to 100 seconds. It's pretty useful. And then to press in, when you press in, you can zoom in on it. Which way was it? Yeah. Here you can see the signal, and then you can zoom in on that part and you can see it better. And then again too. And then you can here set the delay position, like move the signal along, and by pressing it you zero it. Here are also the roll settings, so when you're in very high, like at 100 seconds, you don't see it, so you just press roll and it will capture that signal in roll mode. And then you can, for example, wait for it to roll. Then you can stop it and then just zoom in. And you can see your signal. And you just zoom out and you see nothing. And here you can search for some events. There's the edge, slow, pulse, interval, or runt. And it will just search for them and we'll show you how many events it captured there. And there's the setting, rising, falling for or channel, copy setting, and then there's the thresholds. That's the search, and here on the vertical adjustment there's also there's the channel buttons, there's the digital button if you have the digital device, which I don't have. There are the math functions, which you have the operators plus, minus, multiply, divide, FFT, d over dt, there's dt, and square root. And you choose if channel 1, source A is channel 1, then there can be source 2 would be source B would be channel 2, but I don't have channel 2 enabled. If you enable some channel 3 or 2, then you can do that here to channel 3. And then you can invert one of them, and there's the scale and position. And then there's the reference, where you can save some waveform as a reference signal. That's the source, location. Actually, let me set that to scene. Tough. For reference, like you can set the source channel 1, location, reference A, and you can save it. And it will save this reference. So you can like compare two waveforms with just one channel. And that can be pretty useful. And then you can turn it off or on. So yeah. Next we're gonna look at the utility menus. Here you have the pass-fail. There's the pass-fail output on the back, and you can set a mask. So if a signal goes out of the out of your set mask, it will give out a signal on the pass-fail output. And this is useful if you're like making many boards and you're testing all of them. What else we have here in the utility is the I/O. You can add a certain TP-Link USB dongle and make the scope Wi-Fi compatible. It has a web interface which is very useful, and it is pretty nice. I'll show it off in a different video. And here you can select that. You can check what is the device and set the net interface to VLAN or LAN. And here you can set the IP and enable it. There's also a counter, which is the counts frequency or period or totalizer. And again, statistics and everything there. There's baud plot function, which plots your signal. You can run it, and yeah. There's also data logger. You can update your scope, self-test, and the other options are you can here you can install the functions that the scope offers. That you can buy. It has a you can possibly buy a function generator for it that connects through this USB or a analyzer, so you can make it into a MSO, mixed signal oscilloscope. And here you can enter the codes, and yeah, and for the Wi-Fi dongle sign. Here you can set date and time and time zone, and there's a reference position, power online, and the web server, which is pretty useful. Can set the password for it, and the web server is pretty useful and works very well. Now let me disable the and here you can see the system status, all your startup times, how many startup times, software version, U-boot OS version, FPGA version, hardware version, and product type and everything. And here you can do self-calibration, and here you can turn on and off the sound. I like to leave it on. Change the language. And I'm gonna turn off the counter. What else we have here is the decode, where you can decode serial signals. You can decode I2C, SPI, UART, CAN, and LIN. This can be pretty useful if you work with stuff like that. I don't do digital circuits that much yet, but I might, so it's gonna come in useful. Here the signal threshold and everything. And overall, the scope is very good value for the price, and it will be very useful for me in troubleshooting and working on different projects and showing you how circuits look. And I think that's all the functions over. Oh yes, and here you can also, if you connect USB, you can save a print screen of the scope. So if you want to put it somewhere, like in a YouTube video, like an overlay. So that's pretty useful. But yeah, that's pretty much all the scope's functions. And I have used the scope already for a few weeks now, and it has come in very handy for all sorts of projects and everything, to figure out, troubleshoot and everything. And you will sure see the scope in many other videos from now on. If you have any other questions, post them down below and I will be sure to answer them. So thank you all for watching. See you in my next video. Goodbye.